Mariani. I am second year PhD student and I come from the Università Politecnica delle Marche. My tutor is Professor Francesco Canestrari, and today I talk about my research project, the advanced evaluation of the surface properties of asphalt mixtures. The outline during this presentation, I will talk about the background and objectives, materials and method, results and analysis, and finally the future activities. In the 1960s, the Wehner-Schulze device was developed in Germany. Many research are focused on the correlation between friction after polishing the FAP, so resulting from the Wehner-Schulze device, and polishing stone value, PSV, and investigate the polishing at different aggregate type. The main goal of my research are find a more reliable method to estimate the pavement friction characteristic, find a limit of FAP for the Italian technical specification, and correlate laboratory friction measure with field friction measure. A total of 31 in plant production asphalt mixture was investigated, including 24 open graded, 4 dense graded, and 3 semi-porous asphalt, characterized by different high void content. A minimum of 2 repetitions were tested for each mixture. To produce the specimen, the asphalt mixture were heated in an oven at 160 degrees Celsius for 3 hours. The hot asphalt mixture were then compacted using a roller compactor to produce a rectangular slab 5 cm high. Finally, the slabs were cut in 22.5 cm squares are required for the test. For some sample, the profile was analyzing using the photogrammetry, and 72 photos were taken from each plate. A point cloud was generated by the software, and after the surface was cut with a circular section to generate a surface profile. What is the Wehner-Schulze? The Wehner-Schulze is a laboratory equipment for the study of pavement friction at different stages of polishing. It is composed of 2 units, the polish unit, the left part, and the test unit, the right part. The polishing unit simulates the effect of the tire on the pavement surface by means of 3 rubber rollers rotating at 500 rotations per minute and a mixture of water and quartz powder. The test unit measures the coefficient of friction by breaking 3 rubber sliders on the surface of the sample, whose initial speed is 100 km/h. Now we can see the output of results of the Wehner-Schulze. The first figure shows a single measure of friction. In the test data is interpolated by a 6th-order polynomial to find the friction at 60 km/h. F60 is found for each number of passages to draw the second figure, which is the friction curve. The friction decreases as at the growing the number of passages of polishing. The friction after polishing is the average between 2 at last test. The figure shows the open graded results in terms of friction after polishing. We can see that the skid resistant value at 118,000 are between 0.3 and 0.4. Low friction value after polishing at a number of passages equal to 180,000. The bitumen is not removable in the most of specimen. It is possible to see the binder removal marked with the white circle on the sample on the right. Similar to the previous slide, the figure shows the dense graded results in terms of friction after polishing. We can see how the friction value at 118,000 are relatively high, between 0.4 and 0.5. After polishing at the number of passages equal to 118,000, the bitumen is not removed in the most of the cement, and we can see a residual rubber from the roller on the surface. The polishing area is marked in the picture. Now, in this figure are shown the semi-porous asphalt results in terms of friction after polishing. The performance of this asphalt mixture are positioned between open graded and dense graded. The range of FAP is equal to 0.3–0.4. Only one of the three specimens have a relative high value. After polishing, like other asphalt mixture, the bitumen is not removed on the sample, and the polishing area is marked in the picture on the right. In this slide, we observe three types of surface profile, one for each type of asphalt mixture. In order to analyze the contact area from the rubber slider, a deformation dz has be assumed and the contact percentage has been calculated. Then the zeta is shown in the figure in the left part of the profile. In conclusion, the figure shows the comparison of asphalt mixture, open graded and semi-porous asphalt mixture show a lower friction value than dense graded, probably due to the reduction contact between the slider and the aggregate. The second figure shows the relationship skid resistance as a function of percent of contact. I can divide my future activities into classes, work in progress and coming soon. So, the work in progress core specimen taken from the pavement has been tested, and I will be looking for a correlation between Wehner-Schulze polishing and traffic polishing, as well as between laboratory and field friction measure, for example, the screen measure. Right now, I'm focused on analyzing the data, a lot of data. In the future, we hope to develop a prediction model for skid resistance. So, thank you for your attention. As I always say, follow our adventure in our Instagram profile, scan the QR code and follow us. Thank you.